In this lecture, we will discuss convergence of a sequence in a metric space and Cauchy sequence in a metric space. First is the definition of convergence of a sequence in a metric space. Let Xn be a sequence, sequence in a metric space X, then Xn is said to be converges to a point X in X if 1 for epsilon greater than 0 there exists some positive number, some natural number and not n such that distance between X and X is less than epsilon for all n greater than equal to n. 2 for epsilon greater than 0 for all open sphere as epsilon x there exists some n not belongs to n such that for all n greater than equal to n not implies x belongs to s epsilon x. That is a sequence x in a metric space X is said to be converges to a point X in the metric space X if for epsilon greater than 0 there exists some natural number n naught such that after certain n greater than n naught distance between X and X is less than arbitrary assigned positive number epsilon. Alternative definition, that is second number 2 is the alternative definition of convergence of a sequence in a metric space for epsilon greater than 0 for all open sphere center at this point X and radius epsilon if there exists some n naught belongs to the set of natural numbers such that after some n greater than n naught all the xn belongs to the open sphere center at X and radius epsilon. Okay, after certain and greater than n all the xn belongs to this open sphere center at X and radius epsilon, then we say this sequence xn converges to X. Alright, in that case we say xn converges to xn converges to X written as xn converges to X and X is limit of the sequence X. In that case, we say xn converges to X denoted by this, and this X is the limit of this sequence xn. Next, consider the sequence. Consider the sequence 1 by n in 1 R in the space metric space R and in the metric space 0 1. Then 1 by n converges in R. Okay, this sequence converges to 0 and 0 is the element of R. So 1 by n converges to R and 0 is its 1 by n does not converges in 0 1 as the point 0 to which 1 by n converges 1 by n converges is not in the space 0 1. Okay, else 0 does not belong to this space, so this sequence does not converges. Okay, that means convergence of the same sequence depend on the metric space. That is, same sequence converges in R, but does not converges in this 0 1 semi-open interval 0 1 open at 0 close at 1. And that means convergence of the sequence depend on the metric space, not on the sequence. So write a remark. Convergency convergency of a sequence in a metric space depends on the on the depends depends on the metric space, not on the sequence. Okay, next we are going to discuss the definition of Cauchy sequence in a metric space. Let Xn be a sequence in a metric space X, then Xn is said to be Cauchy sequence if for epsilon greater than 0 there exists some natural number n naught belongs to n such that for all m comma n greater than equal to n naught, after some mn greater than equal to n naught, distance between xm xn is less than epsilon. That is, after some mn greater than equal to n naught implies distance between xm and xm point is always less than 3si positive number epsilon. Okay, then the sequence xn is said to be Cauchy sequence. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.